this lesson, we're going to use unit analysis to convert measurements. This is lesson 8 in your book, and it's on pages 36 through 42. This is a really important lesson because not only do we convert measurements a lot in math, but we use that a lot in science, so it's a good thing to know. So what is unit analysis? This is a process for converting measures into different units, so yards to feet, feet to inches, things like that. When we use unit analysis, we multiply by unit ratios, or sometimes they're called conversion factors. So what are those? They compare two measurements that have the exact same amount, that are equal, basically. So for example, we know that 1 yard is equal to 3 feet. So this is a conversion factor to convert yards to feet. We know that 12 inches is also equal to 1 foot. So this is a conversion factor that converts feet to inches. And 1 meter is equal to 100 centimeters. So this would convert centimeters to meters. Notice that all these are comparing equal amounts. So since the amounts used in a unit ratio or a conversion factor are always equal to each other, those unit ratios are always equal to 1. Since the product of any number and 1 is always that number, a unit ratio multiplied by a measurement will always name the same amount. Now what that means is when you multiply a measurement by a conversion factor, your answer will be the same amount, but it will be in a different unit. Here we have a problem, an example. This one is one you need to write down in your notes. So a cheetah ran at a rate of 105,600 yards per hour. How fast did the cheetah run in miles per hour? Now our directions are find the unit ratio and multiply. So first we need to look at what we know. We know that this cheetah ran 105,600 yards per hour. So what we have is 105,600 yards every 1 hour. That means if that cheetah ran for 1 hour, he would run 105,600 yards. Now we want to convert this to miles per hour. Notice our time is already the same, so we're not going to have to change anything about the time unit. But we do want to be able to change yards to miles. Okay, so off the top of my head, I don't know exactly how many yards are in 1 mile, but I do know that there are 5,280 feet in 1 mile. Alright, now, again, I don't know how many yards are in a mile, but I do know how many feet are in a yard. So that would be some good information to take down too. 3 feet in 1 yard. These are good conversion factors to memorize because they're used pretty frequently. Alright, now what I want to do is I want to multiply my known unit by some unit ratios or conversion factors that will get me miles on top and hours on bottom. So I'm going to multiply by a conversion factor. Now I'm trying to get rid of yards here, so I want to start with a unit ratio or conversion factor that includes yards. So I'm going to look at this one first. Alright, there's 1 yard in 3 feet, or 3 feet in 1 yard. Since in my original unit I have yards on top and I want those to go away, I'm going to put 1 yard on bottom in my unit ratio. That way they'll cancel out. Then on the top, I want the equivalent amount in feet. So 3 feet is what's going to go in the numerator here. Alright, now that's good. That cancels out my yards. Yards divided by yards is unitless. So my unit I'm left with is feet. So right now I'm looking at feet per hour. Now I want to change feet into miles. So I'm going to use my other unit ratio or conversion factor. So I'm going to multiply by another conversion factor. Feet is what I'm trying to get rid of. I'm trying to go to miles per hour. So I'm going to put feet on bottom. There are 5,280 feet in 1 mile. So down here I'm going to write 5,280 feet And in the numerator, I want the equivalent number of miles, and 5,280 feet is 1 mile. Alright, now feet divided by feet cancels out our units, so those go away. And the units we're left with are miles over hours, or miles per hour. Now I'm going to rewrite that as a multiplication and division problem. 105,600 times 3 times 1. And then the units I'm left with on top are miles. All over 1 times 1 times 5,280. And the units I'm left with on bottom are just hours. Now remember, this fraction bar is like a grouping symbol, so I want to multiply all this stuff on top, multiply all this stuff on bottom, and then I'll divide it. When I multiply 105,600 by 3 by 1, I'm going to get 316,800 miles divided by 1 times 1 is 1 times 5,280 is 5,280 hours. And then I'll go ahead and do my division. 316,800 divided by 5,280 gets me 60. And my units are miles divided by hours, or miles per hour. Alright, let's try another one. A mourning dove can reach 35 miles per hour. How fast is that in feet per hour? First, let's start with what we know. The mourning dove can reach 35 miles per hour. 35, and our units are miles divided by, or per, 1 hour. Now we want to be able to multiply that by a conversion factor that will get us feet per hour. Notice our time is not changing, but our distance unit is changing to feet. And we know 5,280 feet is 1 mile. So that's the conversion factor we're going to want to use. So we're going to multiply this by a fraction. I'm looking to get rid of miles and change to feet. So I want miles to be on bottom so that it'll cancel, and feet to be on top so that that's what I end up with. Now I know 1 mile is equal to 5,280 feet. There, my miles cancel, and I'm left with feet per hour, which is the unit I wanted to end with. So I've got 35 in the numerator here, times 5,280, and my unit on top is feet, all divided by 1 times 1, and my unit in the denominator is hours. When I multiply 35 times 5,280, I get 184,800 feet divided by 1 hour, so feet per hour. That's how fast that mourning dove is in feet per hour. Alright, let's look at area. Sometimes we have to multiply by multiple conversion factors depending on if we have units squared or units cubed. So that's what's going to happen with area or volume when you're converting those. So this problem says a gym measures 8.5 meters by 14 meters. The owner bought mats to cover the floor. Each mat is 110 centimeters squared. If 95 mats were purchased, are there enough mats to cover the floor? Now when we're working this problem, we know how many mats were purchased and what their area is in centimeters squared. We need to know if they will cover the entire area of the floor. So what we're going to have to do is figure out the area of the floor, and that's going to be in meters squared, meters times meters. And we're going to have to figure out the total area of all 95 of those mats and see if they're sufficient to cover the floor. But we're going to have to convert centimeters squared into meters squared in order to do that, or meters squared into centimeters squared. First, let's find the area of the gym. The gym is rectangular, we're assuming, so the area of the gym, A sub G, is going to be the length times the width. So 8.5 meters times 14 meters. And when we multiply 8.5 times 14, we get 119 meters squared because we multiplied meters times meters. Alright, now each mat is going to be 110 centimeters squared, and we have 95 of those. So we need to figure out the total area of all 95 mats. So the area of the mats, which I'm going to label A sub n, is 95, how many there are, times 110 centimeters squared, which is the area of each one. And when we multiply those two things, we get 10,450 centimeters squared. Alright, now it's sort of impulse here to say, oh, there's way more area of the mats than there are of the gym, so yeah, there's enough space, there are enough mats to cover the floor. However, the area of the gym's in meters, and the area of the mats is in centimeters squared, so we're going to have to convert one of these. So what I'm going to do is I'm going to convert 119 meters squared to centimeters squared. Meters squared is kind of like having meters times meters squared, because when you square something, you multiply it by itself. I want to convert that to centimeters squared. Now, I don't know exactly how many meters squared are equal to how many centimeters squared, but I do know that 1 meter is equal to 100 centimeters. So I'm going to use that conversion factor. I'm going to multiply this by my conversion factor. I'm looking to change meters into centimeters, so I want these meters that are in the numerator to cancel out. So I'm going to put 1 meter is equal to 100 centimeters. Alright, now, meters divided by meters cancels, but it only cancels one of these meters. So we're going to have to do the same conversion again so that we can cancel out both of those units. 100 centimeters is equal to 1 meter. Now we have this other meter divided by meters, and we can cancel those units out. And we're left with centimeters times centimeters, which is centimeters squared. So I've got 119 times 100. Let's do this. Times 100 centimeters squared divided by 1. 1 times 1 is just 1, so we don't need to do any division there. And when we do that multiplication, we get 1,190,000 centimeters squared. So the area of the gym is 1,190,000 centimeters squared. And the area of the mats is 10,450 centimeters squared. Are there enough mats to cover the floor? Definitely not. So our answer here, the question is, if those mats were purchased, are there enough mats to cover the floor? The answer is no, there are not enough mats to cover the floor.